good afternoon and welcome to this session where I'm going to talk about prioritizing technical debt in automated tests and application code. And I want to do this using a tool called CodeScene. And I want to really emphasize this, that CodeScene is not a code analysis tool. It's a behavioral code analysis tool. And the difference is that in CodeScene, just like a code analysis tool, we look at the source code, but the most important information comes from the behavior of the organization. So we look for patterns in how the developers actually interact with the source code, and based on those patterns, you can prioritize technical debt based on the most likely return on investment, if that technical debt is acted upon. And today, I want to give you an example, and I want to look at the concept that it's not exactly the same as technical debt, but it's very related. It's something called legacy code. So what is legacy code? Well, I found that legacy code has two properties. First of all, it's typically code that lacks in quality to some extent, but most important, it's code that we didn't write ourselves. And I think this is really key because in particular, the second aspect here, because I found that code complexity isn't only about the code itself. Code complexity is also related to the system mastery of us as an organization. So the code that we didn't write ourselves has a much higher perceived code complexity. And this is something we have, I think all of us have seen that. You might have a code base that's perfectly maintainable, then you decide to outsource it, and suddenly it becomes so much harder to evolve that code. But we don't have to take drastic measures like outsourcing in order to create legacy code. And that's what I want to give you an example on now. How quickly can we turn a code base into legacy code? Let's look at an example. So this is an analysis in CodeScene of a code base called ASP.NET MVC Core. It's a framework for building web applications developed by Microsoft. And what we see here in the middle, that's the list of the identified technical debt. We see there are at least two different test suits that pop up as being technical debt with a high interest rate. But the fascinating thing here is that that code base is developed by 178 developers. So let's pretend for a while that I'm a manager here. And one developer says, I want to leave, I found a better job. Now, I'm the manager here, so I say, all right, but I have 177 other developers, so will that really matter? Well, let's find out. So what I did now was that I went into CodeScene and I marked two developers as former contributors. That is people who no longer work on that code base. And what I found out is if the two people leave, the wrong two people, what happens is that we lose mastery of 33% of the code base. So 33% of the code base is written by people who no longer work on the project. This is not a fun fact to get after that event. So what we want to do is to be a little bit more proactive so that we can mitigate such risks. So let me show you how that works. What you see here is a visualization of the same code base. So this is a hierarchical visualization, so that each one of those circles that you see here, they represents a subfolder or a package or a component inside that system. And each file is visualized as a circle as well. And you see that the circles have different size. The color of those circles tells what kind of code it is. So blue means that this is code that's written by developers who are currently part of the organization. And the different shades of gray indicate that this is code written by former contributors. So this is our existing knowledge loss, the 33% I was referring to earlier. Now, let's see what happens if we offboard one developer, a person who works at Microsoft. So to the right here, I have a list of all developers in the code base. And now I offboard dog bounting and see the impact. So what we see here is all those red areas that light up. Those are the parts of the code where we will lose system mastery if that person leaves. Now, how do you act upon this data? Well, what I have found is that there are two different things I look for. First of all, I look for patterns like this, where I have an entire package that gets more or less abandoned. In this case, we see the package is called integration tests, which might be important. If it is, what we should do in this case is that we should check with the other people, the ones that have written the blue code there, and see, all right, so dog mounting is leaving. We lose control of the majority of the code here. Are you comfortable in keep maintaining that? So that gives us an opportunity to be a bit more proactive, but we can do even more. I want to show you one more example here. Because CodeScene can also auto-detect specific offboarding risks. So let's look at a different part of the code base here. And maybe you can see that some of those source code modules are marked with a dashed border. That's something that indicates an offboarding risk. So what is an offboarding risk? Well, in the context of CodeScene, it's made up of 3 different properties. First of all, it's code that has a higher cost. That is, it has a lower code health. It's harder to maintain, harder to understand, harder to evolve. Second, it's code that has a high relevance. Again, so what we do here is we look, is this code that we have spent a lot of development activity on recently? If that's the case, it's likely that we will continue to work with that code. So it's relevant. And then the third aspect is the social dimension. Do we lose active knowledge of that code if that person leaves? If all those boxes tick, then we consider this an offboarding risk. And if this was my project, what I would do in this case is that I would most likely pair that offboarded developer together with another developer and have them refactor that code in order to mitigate the upcoming offboarding risk. So I hope you find this interesting. If you want to see more and read more case studies, please check out my blog at empear.com. And I'm available to talk more about this during a break. So for now, I just want to say thanks for listening to me, and may the code be with you. Thanks.
Thank you, Adam.